Dear viewers, very good morning to all of you. Today, on the initiative started by Punjab EduSet Society and Department of Technical Education Punjab, myself Sukhwinderpal Singh, Senior Lecturer, Department of Electronics and Communication Engineering, SRS Government Polytechnic College for Girls, Ludhiana, is here to discuss the topic of GSM and CDMA, which is under the course curriculum of 3-year diploma in electronics and communication engineering 6th semester under the subject wireless and mobile communication. So, today we will discuss about the GSM, its various features, and CDMA, and then if the time permits, then we will discuss about the mobile tracking, which is the most common feature nowadays, how a mobile working in a certain area is traced or located, which is most commonly known as tower location of mobile, that we will discuss at the end if the time permits. First of all, what is GSM? Its full form is Global System for Mobile Communications. The global mean the system which is used worldwide in the whole globe, in the whole earth, global system for mobile communication. It works on open digital cellular technology. Cellular means that it works on the concept of cells. Each area is divided into cells. Perhaps you all have studied now the cell concept, and it works on the open digital cellular technology, and it is used to transmit mobile voice and data. When the system or the phone is mobile, moving from one place to another, then it is able to transmit the voice and data in while in mobile form. The GSM word, it is originally driven from group spatial mobile. It is in Greek, because first of all the some standard for mobile phone were set up in European countries, and the group was formed of certain European countries, and that were they maintained or they considered about some particular standards, that these standards will be maintained for mobile communication. So, they named their group as Group Spatial Mobile, and it also becomes GSM. So, when the latest GSM technology of second generation was in the existence, then GSM word was taken originally from Group Spatial Mobile, but now the name its abbreviation is Global System for Mobile Communication, and it is second generation, that is 2G system, which is GSM. The features of GSM are: this is international standard for mobile service. As we have already discussed, that some standards have to be maintained for communication between one place to another place. So, internationally the committees formed for maintaining the standards, that they form some standards, and it is named as GSM. So, basically it is an international standard for mobile service, and it offers number of services like voice, SMS, fax, voicemail, and call forwarding, and caller ID. Most of you are already familiar with its certain features. Nowadays, you are transmitting video messages, data messages, picture messages very frequently with the help of internet and your mobile system by loading certain applications. They are very famous nowadays. You transmit or you forward your messages very fast with the help of mobile system. It has the GSM next feature is high mobility is there. The user can be mobile from one place to another place by slow speed, by high speed, or by continuous speed, by random speed. There is no problem, and it has high mobility from one place to another place, and the call does not break in any type of mobility. It has higher capacity. So many users are there in GSM, and there is further capacity, or further it has the space to entertain more users in the existing system. So, it has higher capacity, and the most important feature of GSM is it has worldwide roaming. Roaming is worldwide, that one person from one country where GSM standards are being followed, and if he has the GSM enabled handset and the GSM enabled SIM, then it can be used worldwide from any place where GSM is used to any place where GSM is being used, but with the acceptance of the MSC of that place, that if the main switching centers of both places, both countries are agreed, then there is no problem between the call the call making from in one country to another country. So, it has the important feature of worldwide roaming. Frequency bands in GSM are, there are three types of frequency bands in GSM. They are dual band, tri band, and quad band. Three types of bands are there: dual band, tri band, and quad band. In case of dual band, it has, as the name implies, it has two frequencies. Dual band means two type of frequency bands. It operates on 900 megahertz and 1800 megahertz. Mobile phone supporting dual band can be used in world where 900 megahertz and 1800 megahertz frequencies are used. Our phone can be dual band or tri band or quad band, and if the service provider has also the dual band which operates on 900 megahertz and 1800 megahertz, then our phone can be used worldwide throughout the world where 900 megahertz and 1800 megahertz frequencies are being used. It is found, or it is used in all continents in whole world, usually that is Europe, Asia, Africa, Australia, and South Africa. Dual band is being used in the all continents. Then tri band, here one more frequency 1900 megahertz is also supported in this tri band, other than that two frequencies. It so now in tri band there are three bands which are 900 megahertz, 1800 megahertz, and 1900 megahertz, and it is also supported worldwide, that where these three frequency bands are being used, then mobile system can be used throughout the world. Quad band, as the name implicates, it will have four frequency bands. So, other than the first three frequencies, one more frequency band of 850 megahertz is also used there. So, four frequencies are supported in quad band, which are 850 megahertz, 900 megahertz, 1800 megahertz, 1900 megahertz, and it is also supported worldwide like the other two, that is dual band and tri band. So, GSM network areas are, what are the GSM network areas? First of all, the basic network area is cell, the basic geographic location or the basic geographical area, that is cell, then location area, then MSC or VLR service area, then PLM. These are the various GSM network areas. So, what is cell? Cell is basic service area covered by one BTS, that is base transceiver station. Basic service area which is covered by or served by one BTS. The towers which we are seeing in our cities, in our localities, there are so many mobile transmitting towers. They are the basic BTS or the base transceiver stations. They serve one cell, that is one basic geographical area, and each cell has unique number which is known as cell global identity, that is CGI. Each cell has its unique number and it is known as cell global identity. No other cell has this number. Then location area, it is group of cells. The group of certain cells is called location area. The location area is the area which is paged when a subscriber gets incoming call, and each location area is provided a unique location area identity and served by one or more BSCs, that is base station controllers. So, location area is a group of cells, because a mobile phone in one cell is served by more than 1 or 2 or 3 BTS. When we see the cell info over our mobile phone, we will see that within certain time we are getting the mobile cell info of 1 BTS, which is very near to our location. Then another BTS which is very near to another our location in the opposite direction, and then we get the cell info of any other BTS. For example, if we are locating in the sector 17 of Chandigarh, then we will get BTS of, when we check the cell info, we will get the location as, first of all we will getting sector 17 Chandigarh, then we will get sector 22 Chandigarh, after that we may get sector 9 Chandigarh, which sectors are nearer to our location. When we go to another area, then also we will get the cell info of certain cells, certain BTS that are more than one BTS, because our mobile is being served by all the nearby BTS. So, the area location area is the area which contains the group of certain cells, and when we get any call on our mobile phone, that is when a subscriber gets incoming call, then whole area is paged, that is whole area is located, because the subscriber can be served by any of the BTS in that location area, and each location area is provided a location area identity which is unique for every location area. No other location area has this identity, and it is served by one or more BSC, that is base station controller. Then PLM, it is the area covered by one network operator. One network operator, like if Idea is covering certain area, whole Punjab is served by the Idea, then that area is called PLM. If whole Punjab is covered by Airtel, whole Punjab is covered by Vodafone, whole Punjab is being served by BSNL, that area is called PLM, and it can contain one or more MSC, main switching centers. It can be one for one PLM or more than one for one PLM, as per the requirement or as per the capacity of the network operator. This is the GSM system architecture. It is divided into three parts. First is the base station subsystem, then network switching system, and then public networks. Here this is stationary mobile station, the mobile phone which is stationary at one location, and this is mobile phone moving in a vehicle, in a car, it is shown here. There are two mobile stations are shown, one is stationary and other is moving in a vehicle. This mobile station can be connected to any BTS base transceiver system located nearby its location. Similarly, in this it can be connected to any BTS which is located nearby to this mobile station, and then all BTS they are connected or they are served by BSC, that is base station controller. And then this BSC, these all BSCs base station controllers are connected to MSC, that is main switching center, which is the main switching center or the main part or network switching system of any service provider. And in MSC it has HLR, that is home location register, VLR visitor location register, and AUC authentication center, and operation and maintenance control are also in MSC system subsystem, that is network switching subsystem. And then these are further connected to PSTN, public switching telephone network, integrated services digital network, and certain data networks, they are public networks. So, whole GSM system architecture is it can be divided into three subsystems, that are base station, which is the base station is our mobile system, our mobile phone and SIM, then the tower located nearby and the BSC serving to these BTS or the towers, and then another system is the network switching subsystem, which is MSC, and certain its registers and operation support subsystem, and then public network to which our MSC is again connected or interfaced. So, this is the GSM system architecture. Basically, as we have already discussed GSM network stages, it has three parts: base station, network switching, and public network. Mobile services switching center. It performs the switching of calls between the mobile and network users, and management of mobile services such as authentication. The mobile services switching center MSC mainly or main switching center, it performs the switching of calls between the mobile and network users, and it manages the mobile services such as authentication of call and authentication of the user. Now, we will discuss one by one all the blocks of GSM system architecture. The mobile station, it is basically our mobile set and the SIM. The mobile station consists of the physical equipment. First is the radio transceiver, digital signal processors, and subscriber identity module SIM. The set without SIM is the radio transceiver, which can transmit data, transmit radio waves or receive with radio waves, and it contains digital signal processors, processors to transmit the radio waves and processors to receive the radio waves. And then when we insert the subscriber identity module, that is SIM, in this our radio transceiver, it becomes the mobile station, and it provides personal mobility, personal identity also. By inserting the SIM card into another GSM cellular phone, the user is able to receive calls at that phone. We all know that if we remove our SIM from one phone and we insert into another GSM enabled cellular phone, then we are also able to receive our calls at that phone. Then that phone or that hardware becomes our mobile station when we insert one particular SIM in that phone. This is the reference architecture and signaling interfaces for GSM. This is the cell area in the hexagonal shape and served by one BTS. One tower is serving it into this cell, and then these cells are served by BSC. Then this BSC is served by MSC, and MSC is again having VLR, EIR, HLR, authentication ECE, and EIR, equipment identity register. Whole data is there in MSC contained in this certain these types of registers HLR and VLR, EIR, and it is again connected to PSTN, public switching telephone network. And this another MSC, it is also connected to certain other BSC, then that BSC is connected to certain another BTS. This is how the whole GSM model is working. The SIM card contains the international mobile subscriber identity. Our SIM card has the international mobile subscriber identity. One SIM card, there is a number printed on the back of every SIM card. That number is the unique number, and it is international mobile subscriber identity. No another SIM card has that number. And first 3 digit of the SIM card printed on the back side of SIM card are their country code. In India, you will find that every SIM card in India, regardless of which company it is, it will have the country code 899 in as the first 3 numbers as the India country code. So, you can check that every SIM card will be having 3 digits as 899, and each SIM card has the unique number which is called international mobile subscriber identity. And the SIM card may be protected against unauthorized use by a password or personal identity number. We can add the PIN, that is personal identity number, that is called PIN PIN or password, where so another no unauthorized person can use this SIM card. Then base station subsystem, it is composed of 2 parts as we have already discussed. They are base transceiver station BTS and base station controller BSC. So, BTS, it is base transceiver station, it handles the radio link protocols with the mobile station. This BTS, it handles the radio link, radio waves are transmitted from BTS to the mobile station located in certain cell area, certain geographical area, and it is providing radio link to mobile station in this area and from mobile station in that particular area. Then BSC, base station controller, it handles radio channel setup, frequency hopping and handovers. This BSC, this is radio channel setup, because which mobile phone requires to call or requires to outgoing call or require incoming call, then that mobile station is connected with the help of its BTS to BSC and then to MSC. So, each call, it is when there is a call forwarding or call receiving, each call is happens through the main switching center through BSC and BTS. BSC is the connection between the mobile and the mobile switching mobile service switching center, that is the mobile set in any cell and mobile switching center, main center or main switching center of any service provider. So, each call is provided or is a connection made between the mobile station in any cell with the MSC, and this connection is done with the help of the base station controller BSC. The functions or physical elements located in a BSC and BTS are: in base station controller BSC there is BSC processor, then control of BTS are there, radio resource management is there, and handoff management and control is also there. You must have studied up about handoff till now. So, handoff is also managed by the BSC, base station controller, that call is how the call is transferred or how the call is taken from one BTS to another BTS while the call is processed and user moves from one cell to another cell. That handoff management and control is also done at the base station controller. In BTS, that is base transceiver station, there are BTS processor, radio transceivers, equalizer, channel coders are there, transcoders are there, then encryption unit, that is coding is done there, and interleaving and de-interleaving is done in BTS, combiners are there and pre-selectors are there in BTS. So, these are the physical elements located in a BSC and a BTS. Now, about MSC, mobile switching center or main switching center. It is the central component of the network subsystem, the main system or the main central component of network subsystem. It acts like a normal switching node of the PSTN or ISDN, because when the call is made, the call can be between our mobile station from within the same to the mobile station within the same MSC range, that is we can say that idea to idea, or same MSC to same MSC, that is Punjab idea to Punjab idea is same as MSC to MSC, then Punjab Airtel to Punjab Airtel is same MSC to same MSC. But if from Punjab idea to Delhi idea or Haryana idea or any other part of idea, then MSC will be changed. So, this will affect ISD, that is the subscriber trunk dialing is used in that case. So, that is in that case the MSC acts like a normal switching node of the PSTN or ISDN, that is another it connects with another MSCs, another MSC of same state, another MSC of different states, or the BSNL, that is landline PSTN, public switching telephone network, or integrated services digital network, another kind of networks. So, this is the normal switching node for mobile station to another networks. The role of MSC is registration, authentication, location updating, handovers, and call routing to a roaming subscriber. The registration of every customer is there, and it is contained in the HLR, that is home location register of any MSC. Then authentication is there, that say the original or genuine user is talking, that is authenticated by the MSC. Location is always updated, that at certain time from where the call was made and the cell was at what location at that certain point, that is also recorded in MSC registers. Handovers are also controlled in MSC, and to a roaming subscriber, call is routed from one user to another user. The home location register HLR, it contains all the administrative information of each subscriber registered in corresponding GSM network and current location of the mobile. The home location, as the name implies, where is the subscriber or the mobile station located. The current location is always there in the HLR. Then its certain profile data, its address, its name, its certain profile, that is administrative information of each subscriber in any GSM network, that is also fed in the, or it is also contained in the home location register HLR. Then visitor location register VLR.